Welcome to AudioBench Academy Foundations. In this video, we're going to walk through the core ideas behind how AudioBench works. We'll look at modules, ports, connections, parameters, and more. Once you understand these concepts, building and exploring with AudioBench becomes second nature. Follow along with the visuals on screen and check out future lessons for deeper workflows and hands-on examples. AudioBench is a modular audio laboratory. It lets you assemble, control, and visualize audio and control signals in real time. It's designed for prototyping, education, exploration, and building unique processes that can't be made with anything else. Anywhere you need a flexible DSP environment, AudioBench gives you room to experiment. Modules are the building blocks of every AudioBench document. Each module performs a specific task. It might generate audio, process it, route it, analyze it, or control other modules. Every module has a name, a color, and optional notes you can add for reference. And many modules can also be muted or bypassed. There's no limit to how many modules you can add to an AudioBench document. If your document becomes complex, you can group related modules into a box. A box can have inputs and outputs of its own, allowing you to simplify your document and keep things organized. Ports are the connection points on each module. Input ports appear on the left side of a module, and output ports appear on the right. Some modules, like mixers and splitters, let you choose how many ports they have. Every port accepts a specific kind of data called a payload. The payloads define the meaning and structure of the information moving through your system. Let's step through the different kinds of payloads that are available in AudioBench. First is the audio payload. This is real-time PCM audio running at 48 kHz. It represents the time domain signal that you hear. Then we have control payloads. A control payload is a single numeric value that adjusts how a module behaves. This includes slider positions, knob values, LFO outputs, random number generators, scale factors, and much more. Most control sources output values between 0 and 1. Because of that, you'll often scale or shape these values so they fit a range expected by another module downstream. And finally, there are bundle payloads. A bundle is a structured group of numbers treated as one unit. Bundles are used for algorithmic configuration, things like filter coefficients, magnitude values, FIR kernels, and other multi-value parameter sets. All ports on a module are set up to use a single payload type at a time. One exception is the universal port, which is shown in white when disconnected. A universal port will accept any payload type. But when you connect to a universal port, other ports on the module may adapt to match. And how this works depends on the module. Some modules will make their opposite port match the connection you just made, and others can handle multiple different payload types at once and will combine them intelligently. Here's how that works. If there's an audio payload and a control payload, the control value will be applied to all of the samples on output. If there's a bundle payload and a control payload, the control value will be applied to all of the values in the bundle on output. If there's a bundle and an audio payload, they'll be combined in a way the module determines, and the output will be an audio payload. A connection links an output port on one module to an input port on another. Each port can only participate in one connection. This keeps the signal flow clear and predictable. A tap is a special type of connection, and it's represented by a dashed line. A tap lets a module listen to a signal without affecting it. Taps are useful when you want to monitor or analyze the signal without interrupting its flow to its primary destination. Some modules are designed to only have tap inputs, such as payload converters and modules that display their payloads in the console. Modules expose two types of adjustable values: properties and parameters. Properties define the structure or configuration of a module. This includes settings like port counts or font sizes. Properties usually do not change while the engine is running, and they cannot be driven by other modules. Parameters are real-time controls. They can change while the engine is running, and every parameter uses the control payload type. Parameters can also be published, which turns them into input ports so that other modules can control them. When you run your AudioBench document, it analyzes and builds an optimized engine that handles all of the audio processing, while staying connected to your controls on the console. Each module included in the processing displays a green indicator in its upper right corner. This lets you see which modules are running in real time. If a module isn't connected, directly or indirectly, to an audio input or output module in your document, it will be ignored and won't be used during the run. AudioBench renders the audio in batches of samples at a time in order to optimize processing during runtime. You can control how many samples there are in these groups, with the trade-offs being between latency and CPU load. The smaller the number of samples in a group, the faster AudioBench will respond to live input, but it may also use more CPU time. Monitor the CPU usage gauge during running to see how much is being spent on audio processing. These are the core principles that define how AudioBench works. By understanding modules, ports, payloads, connections, properties, and parameters, you can build systems that are both flexible and powerful. In upcoming videos, we'll explore real workflows, build complete signal chains, and show how these concepts come together in practice. Thanks for watching, and continue exploring with AudioBench.